times where I felt like this rule was applicable and did it. But the point is, just like in the derivative, coefficients are sticky, not constants. There's a difference between a coefficient and adding on a constant. When you add on a constant, that's addition. But when you have a coefficient, that's multiplication. So when you have a constant being multiplied, that thing just sticks around and lingers and just hangs out. So let it do its job, let it just sit there and wait to use it. So like this one, 5x minus 2 dx. I could split this into two integrals, but again, in practice, no one really does that. You're just finding the antiderivative of 5x minus 2, which means you want to find the antiderivative of 5x, which you find by adding 1 to the power and then dividing by the new power. Minus the antiderivative of 2, which will be 2x. And then we always add on our arbitrary constant. This next one, which I may not quite have the space for, we'll figure it out though. You need to rewrite this before you can do anything. The square root of x is x to the 1/2. And again, just keep in mind what this thing is asking of you. It wants you to find the antiderivative of the thing in the middle. And the thing in the middle has two parts. The antiderivative of x to the 1/2 will be add 1 to the power. 3 over 2 over 3 over 2. This coefficient 3 is attached. It stays. Add 1 to the power, you're going to get 5 over 2. Plus c. And again, I don't so much care if you actually simplify this. Let's just take a look at it. Hopefully this is starting to make sense. Two more examples, and these are the hard ones. There is no rule for multiplication or division in integration. That looks like an S. Let me try to write that better. It's supposed to be an integral sign. Oh no. Which means your only option here is algebra. We're going to rewrite this. And we've done this before in the very beginning when we began derivatives. I'm going to separate and do some algebra. 4x to the 4th divided by x squared. That's an equal sign, by the way, in case you can't understand it. Oops. Would be 4x to the 2nd minus 5x. Then we add 1 to the power, so really you're just pulling this one out. You get 4x squared, add 1 to the power, and divide. Minus 5x squared over 2. Don't forget your plus c. That is the answer. Number 4 here, same idea. There is no rule for multiplication or division, so your only recourse is to do some algebra. Distribute this through. This would be 3x to the 6th minus 15x to the 3rd. And then from here you add 1 to this power, add 1 to that power, divide by both of them. So you keep the 3. So again, remember, you are also dropping the integral sign and dropping the dx because they are nothing but notation. All these symbols are telling you is to find the antiderivative of this thing. So you're just going to pull out the 3, add 1 to the power, and divide. Keep the 15, add 1 to the power, and divide, and add a plus c. So again, the integral sign and the dx are nothing but notation. When you see them, no one has to give you instructions. It means find the antiderivative using x as the variable. So when you come up with the conclusion, you are finding the function whose derivative is the thing trapped inside of the integral. Okay, so the antiderivative of e to the x. Think about it, everyone. What's the derivative of e to the x? So if I want you to find the function from which e to the x came, so e to the x is someone's derivative, the answer is e to the x. Oops, again, I can't scroll up. Okay, so I'll try to leave that there so I'm not ruining things too much. The antiderivative of e to the kx, it's very much the same. The antiderivative of e to the kx is e to the kx. But when you would find the derivative, you'd multiply by the derivative of the power, which is k. When you find the antiderivative, you divide by k. Now we'll look at the antiderivative. Oops. That's at the bottom of the last page. Let me go back. And I'm going to have to move stuff around again. And we have to erase some of it. Oh my, this is going to be pretty tragic. Okay, I'm going to pause and try to figure out how to make this work. Okay, I sort of got it. So the next one is actually the indefinite integral of x to the negative 1, or 1 over x. So think about that. What function has 1 over x as its derivative? I don't want to give the answer too soon. I want you to really think about it. The answer is the natural log of x. And we put the x in absolute value bars to help with a domain restriction, because ln can only have positive input, but 1 over x can have anything except for 0. It's the only exception I have written right here. Please pay attention to this. This is the only exception to the power rule. When the exponent is negative 1, you cannot add 1 to the power and divide. Why not? If you added 1 to the power, you would get x to the 0, and then you would divide by 0. That's bad. You can't divide by 0. That should tell you that that's not the right approach. So when you have x to the negative 1, do not add 1 and divide. That is not the way you do it. It's the natural log of x. Here are some examples. Again, that was because the derivative of the natural log of x was 1 over x. So this should not be that bad. Let me make sure I can scroll up and down all the way first. Okay, good. The antiderivative of 2 over x. Again, the 2 is a coefficient. You may not be aware of how this works, but the 2 is going to stay. We're taking the antiderivative of this. But since the x is in the denominator, this is 2 times the natural log of x. The antiderivative of e to the negative 2x is e to the negative 2x. You divide by negative 2. The antiderivative of 5 is 5x. And then you add c to it as always. 2 over x squared minus 5 over x plus e to the 0.1x. I'm looking for the antiderivative of 2 over x squared minus 5 over x plus e to the 0.1x. So, you at least need to rewrite part of this. 2 over x squared cannot stay. We have to make this 2 times x to the negative 2. The 5 over x can, because hopefully you recognize that's the natural log of x. So then from here, you add 1 to the power for 2x to the negative 2, which will become 2x to the negative 1 divided by negative 1 minus the 5 over x. 5 over x. This looks just like 2 over x in the problem before. So this should be 5 times the natural log of x. We have not seen an e in an example. Oh, we saw an e in the last one. I lied. This is e to the 0.1x, which remains exactly the same. The only additive thing that you do when you find the antiderivative is instead of multiplying by that 0.1, you need to divide by 0.1 and add c. Now we have an application with a typo in it. This is the word fixed. The marginal cost function to produce x mugs is given by c prime of x is equal to 0.2 x squared plus 5x. We know the fixed cost is $8. Find the cost function. So they are giving you a big hint here by saying c prime of x, which is the marginal cost. But we know we have the derivative. So what is the relationship between the cost function and the marginal cost function? I would hope you know that the cost function, well, I guess I should say this, marginal cost is the derivative of cost function. But if I'm looking to find the cost function, therefore I have to think of it the other way around. The cost function will be the antiderivative of the marginal cost function. It's as if the antiderivative cancels out the derivative. That's what happens here. So to find this cost function, I need to take the antiderivative of 0.2 x squared plus 5x. Again, I hope this scrolls down more, not much more. Don't forget the parentheses and the dx. This will therefore be, I'm going to drop the extra 0. It's going to be 0.2 x cubed over 3 plus 5 x squared over 2 plus c. And that's where things get interesting. This is a real-world problem. Do you think it makes a lot of sense to have a random plus c floating around in it? Probably not. That's where this piece of information comes in. The fixed cost is $8. The problem I often see is that people are not really truly aware of what it means for something to be a fixed cost. What this means is the cost when nothing is made. That's really what the fixed cost means. That's what it will always mean. The fixed cost is the cost when x is 0. So this then means in mathematical language that x is 0 and c of x is 8. So here's my cost function. We did find it. C of x is 0.2 x cubed over 3 plus 5x squared over 2 plus an unknown constant. But I now know a way to find this c. I can substitute in, here we're back to here, I can substitute in 0 for x and 8 in for the c of x. So 0 in for these two x's and 8 in for this c of x. Where I'm going to do this math is a whole other story. Probably over here to the right since I think it'll let me go there. So I'm substituting 8 in for c of x, and then we'll have 0.2 times 0 cubed over 3 plus 5 times 0 squared over 2 plus c. This is 0 and this is 0. So 8, c is 8, I should say. So really to finish the story, the answer is 0.2 x cubed over 3 plus 5x squared over 2 plus 8. That is your cost function. That is the final answer to that question. And that's the end of our lecture.